Hey everybody, and welcome to our first Algebra 2 class. So as we start off this school year, you've heard from me already that we are going to be flipping this class. So all of our instructional videos will be pre-recorded like this one, and then during our live sessions, we will do extra practice problems, answer questions you have, and just clarify some of the topics that maybe are a little bit more difficult. The start of Algebra 2 is going to be looking back into functions, which is an Algebra 1 topic, but we're going to dive back into it again. We're going to add a little bit to it, so not a huge amount. It's mostly Algebra 1 content with a little bit of Algebra 2 level stuff sprinkled in as well. Okay, so for this particular lesson, we're going to look at domain and range, and we're going to look at how to write those using intervals. And then we're going to also look at the end behavior of functions. So you're going to be able to describe both of those. The essential questions are the things you should be able to answer by the end of the lesson. And if you can answer those, you know you've gotten out of the lesson what you were supposed to. If you can't answer them, you should go back through the video again and try and find the answers to those particular questions, or Google them, or ask me during our next live session. All right, looking at functions. First question is, what is a function? So in your heads, try and answer that quick. What is a function? So a function is a relationship between a set of inputs and outputs. You're going to put something into a function, which is like a set of rules, and then an output is going to come an answer. And the key thing with functions is that every number you put in, every input has only one output. So you can't put a number in and then get two answers out. You can only get one answer for every number you put in. When we see it visually, it makes a little bit more sense. We use what's called the vertical line test to test that. So if we look at the diagrams over here, the top one is not a function because when we draw a vertical line, it hits the function in, or hits the graph in three places. So this one is not a function. Versus the linear function down here, any vertical line is only going to hit it once. So for every x value, there is only one y value. So that's the unique part about a function versus an equation, which is just where two sides of an equal sign balance each other. Two expressions are equal in value to each other. So functions have an equal sign in them, but they are a subset of equations. So a function is an equation, but not all equations are functions. This graph is something that I find really important. I normally hang it up in my classroom as well. There is a copy of this as a picture in your Schoology folder. I highly encourage that you go find it, either print it or make a copy of it in your own notes, make a poster of it and have it displayed up in your study area. This is going to tell you pretty much everything you need to know about parabolas and then functions as well. So when we look at something like this, things we want to try and determine, describe the graph. So opens upwards, there's, it's a parabola, so it's a quadratic graph, opens upwards. So that's going to give you some indication about what the equation of it should look like. The intercepts or the roots are typically important values for us. We know when we did quadratics in Algebra 1, we spent a lot of time trying to find what those x values were. So solving a quadratic was another way of finding the x roots. The vertex or turning points are going to be important points for us, so we're going to have to try and determine those. Your calculator will do a lot of that for you. If you need a recap on that, just look on YouTube or Google how to find turning points using TI-89 or using Desmos, something like that. The y-intercept, also an important point, typically because a lot of functions, the x-axis is time. So we usually want to know at time 0 what was the value and then moving on from there. Finally, today's main focus is domain and range. So domain is the possible x values that belong to a function. The range, the possible y values. Now by possible I mean that there is a value on the graph for that particular x or y value. So we notice on the range that there is a dot, there is a point where it starts. Because this is a parabola, it has a turning point, there are no points on the graph lower than that vertex. So that is going to be the bottom part of our range, and then it goes up forever. And you will notice that most graphs will have arrows, but some of them will not, and I'll show you an example of that in a second. Both are indicating that that graph is going to follow that trend forever. All right, so domain is typically the x values, but we have to bear in mind that not every function is going to use x and y. Sometimes they will use a's, b's. It just really doesn't matter. Domain is the input, what you put into the function, and then the range is what you get out of it. And in a function, it's usually going to be a y value for coordinates or f of x, which we'll see in a second. And then end behavior is asking us, well, what happens as the graph gets, so as the x value gets bigger? So as we move to the right, what is the y value doing? What's the trend of the graph? And then same thing with the left. So as x gets smaller, what happens to the y values? What's the trend? All right, so just take a look at this graph. It's a quadratic graph again, so a parabola, and just describe it. What is the domain of this graph? So now notice, the graph goes all the way up to the edge, but there's no arrows. We can assume that that means this graph is going to go on forever. Unless you see a point to indicate, this is it, that's it, the graph is done, you assume that it's going to go on forever. So if we are thinking about the domain, this graph is going to go forever to the up and right and forever to the up and left in both directions. So there is, it's still going to the right as it moves up. It's not vertical. So that means that there's going to be a y value for every possible x value we can think of. So we would say all x values, or all real numbers. Anything that is between negative infinity and positive infinity will work. Describe the range. Well, the lowest value is -3, and then it just goes up forever. So we would say like anything greater than or equal to, because it can be -3. So anything greater than or equal to -3. And I apologize for my handwriting. It's hard to write with these tablets, but it's gotten a lot better than when I started in the spring. Describe the end behavior. So it's going, up for both. Now, this is not the, of course, appropriate way to describe this, but just visually, like for both directions of x are getting smaller or getting larger, the y values are going higher. So it's going up in both cases. We will write these all in the proper form in a second. All right, an interval is how we are going to describe the domain and range. An interval is just a start point and end point and everything in between. So it's a small segment of the number line. There's 4 ways that we represent intervals. First one is going to be on a number line. And this is what you would have seen when doing inequalities in like middle school and Algebra 1. You would put your inequality on the number line to show all of the values between the two that you were talking about. Remembering that closed circle meant included. And test your knowledge, what's not included? It's an open circle. We have inequality notation. So typically what you were doing in middle school is you were looking at something like this and you were putting it on a number line. Inequality notation, you've got the lowest value, less than or equal to x or y, so are we talking about domain or range, and then the highest value. So what x, we're saying here x is between and can include -3 and 7. You've got set notation. Now this one's probably one of the least used ones, but you should have done this in Algebra 1, but just in case, you're going to have what you're talking about, so which variable are you talking about, a vertical line, which is this such that part, so such that, and then you just take the inequality, so whatever the inequality was from inequality notation, it just goes in after that, and then you close it off with a set bracket. Practice those set brackets because they do actually take a little bit of thinking to get that nice squiggle bracket. And then the last one is interval notation. This is the one that's my favorite. I will use it probably the most in my examples, pretty much because it's the fastest. And all you're going to have is the lowest value, the highest value, a comma in between them, and then you've got to figure out which type of parenthesis you're going to use. So in this case, lowest value, highest value, figure out your parentheses. A square bracket means that the number is included in the answer. A round bracket means it is not. And just like a note for yourself, infinity or negative infinity is always going to have a not included. You can never reach infinity. It's a value that something approaches. It's an idea. Let's take a look at an example. So this one is written in function form. We have f of x and that is equal to 2x. And then there was also a limited, now if we're talking about x, this is a limited domain. So the range, the output, is going to be the answer. The domain is what's inside here. So this is the variable that we are treating as the domain, x. So as we change x, what happens to the answer? And we can see in the equation where that domain is going to be affected. So this function is saying, all right, for every number between 0 and 7, 0 not being included, that we put into the function, we will get an answer, and that's going to be part of our solution. So let me erase the overlap here. So f of x is the range, and we got the domain, yes. So we're going to write these in their different notations. Inequality notation, what's the lowest value of the domain? Well, it's actually kind of nice because we've got it given to us in the question. 0 is the lowest value for the domain, less than x, less than or equal to 7. Set notation, we get our set bracket. We're talking about x, vertical line such that, and then our inequality goes in the exact same. And then interval notation, lowest value 0, highest value 7. 0 was not included, so it gets a round bracket. 7 was, it gets a squared one. Over to range. Now this is the one where you have to think about it a little bit. If I put 0 in for x, 2 times 0, so f of 0, 2 times 0 is 0. If I put 7 in, so 7 instead of x, 2 times 7, the answer would be 14. So the range is going to go from 0 to 14. Now, if you recognize this, this is going to be a linear function. So 2 times x is going to be linear, slope of 2. So that just means that it's starting at 0, 1, 2, and this will be 214, and it's just going up, and there's an open circle at the beginning. So the range, lowest value is 0. It's still not included because the x value 0 is not included, and that's the answer we got for an x value of 0. This time we were talking about the range, which is f of x, and that's going to be less than or equal to 14 because 14 was the answer when we put 7 in, and 7 was included. Set interval, now we're just pretty much copying what we did above. So we were talking about f of x such that 0 less than f of x less than or equal to 14. And a common question I get is, well, can I just use y instead of f of x? My answer will be match whatever is given to you in the question. If this one had said y equals 2x, then we'd be using y, but since it says f of x, we're going to use f of x. If it's from a graph, it's up to you. Interval notation, lowest value 0, highest value 14, and the brackets will match what happened in the domain. 0 not included, 14 is. All right, let's take a little bit of practice on that quadratic we saw a couple minutes ago. So we described it verbally. Let's try and write it correctly now. So if we are talking about all x values for the domain, so any x value goes, we would say the lowest it can be is negative infinity. So it's going to go forever in the negatives. It cannot equal that, so it's going to be negative infinity less than x, which is less than, on the other side, positive infinity. So it's going to go up forever in all directions. Set notation, squiggly bracket, x such that minus infinity less than x less than positive infinity, close it. And interval notation, lowest value negative infinity, highest value infinity, both get round parentheses because neither is included in the answer. Range, now the range is the one that's a little different because it has a lowest value. So minus 3 is our lowest value, and then it goes up forever. So minus 3, is it part of the graph? So is there a point at minus 3? And yes, there is. The vertex is at minus 3. So less than or equal to, now there's no function notation given to us here, so I can call this f of x, or I could call it y. It doesn't matter. I'm going to use y. less than, goes up forever, so it's going towards positive infinity. And that less than or equal to symbol bothers me. There. Set notation. Set bracket, we're talking about y such that -3 less than or equal to y less than infinity, close it. And then interval notation, -3 infinity. We know infinity is always a round bracket. -3 is included, so it gets a square one. That's it. Looking at end behavior. So end behavior, remember, is what is the graph doing as we go towards the extremes? So all the way to the right, all the way to the left, what is the behavior of the graph? What's it looking like? How we're going to write this. As x goes towards or moves towards infinity, f of x moves towards blank. Or as x becomes infinity, f of x becomes what? And this is usually the part we have to fill in. Same thing on the other direction. As x goes towards negative infinity, what is y doing, or what's f of x doing? Let's take a look at a graph again. So the same one we just looked at. As x gets larger, what's happening to y? It is going up, and it's going up towards infinity. So we're not concerned with what's going on in the middle here. We want to know about the extremes of the graph. So as it goes towards infinity and minus infinity, what is happening to the y values? So we would say, in this case, as x goes towards infinity, y, or f of x, is going towards infinity as well. As x goes towards negative infinity, also going towards infinity. All right, what about this one? End behavior. As x gets larger, the y value is getting smaller. So we would say as x goes towards infinity, and there's nothing here except for y, so y goes towards negative infinity. Other direction, as x goes towards negative infinity, y goes towards negative infinity as well. So as we go left, the y values are getting lower, so they're going towards negative infinity on both sides. All right, this one's asking for the domain of the function. So this one is a function. This is called a root function. So this would be something like, yeah, I think this is square root of x. So f of x equals square root of x. So it is, the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and so on. So the next one we would expect to see is 9, 3. Domain in this case, well, the lowest x value is 0. The highest one, it's going forever to the right and up, so it's going towards infinity. Infinity gets a round parenthesis. 0 has a point, a closed circle, so it is included. So this would be our domain. Now let's just say we wanted to ask about the range. Lowest value for y is 0. It's going up forever, so the range would actually look the exact same. Now, this one doesn't really have an end behavior because it has a fixed endpoint. So you don't typically see end behavior questions if there are endpoints to the function. So it doesn't just go on forever as in some sort of direction. But if we were to say it like as x goes towards positive infinity, the y value is going to continue to rise. It'll go towards positive infinity as well. The other direction just doesn't work. It's not going towards negative infinity. Sometimes, like if it's an exponential function, you might see something like that, but at the moment, that's it. All right, this one. There's 2 endpoints, so it doesn't go on forever in either direction, which is why we're not asked about end behavior, but take a shot at it. I want you to pause the video after I finish explaining, and then take a shot and then come back. So you're going to write the domain and the range using all 3 notations. Pay close attention. There's open circles and closed circles. And there's values in here. You can zoom in if you need to. All right, pause the video, take a shot at it, and then come back. All right, welcome back. So let's take a look now at the domain. The lowest x value is 16. It has a closed circle, so 16 is included. And 65 is the highest, but it has an open circle, so that is not included. So set notation x such that 16 less than or equal to x less than 65, close it. And interval notation 16, 65, 16 is included, 65 is not. All right, switch over and do the range. Lowest value, 100. Also close circle. We can use y in this case, and 4,342.74. Set notation. Y such that 100 less than or equal to y less than 4342.74. And interval notation, 100 is the lowest point, 4342.74. 100 is included, 4,342 not included. Now, just in case you were wondering what this graph was, this one is time, or really it's age, and then this one is dollar amount. So the graph would tell us that if at 16 years old you put $100, so at 16 you put $100 in an investment account, and the equation here is 100 times 1.08 to the power of x. So x is the number of years. So we're saying, okay, number of years minus 16. So it's starting at 16. And it will grow at 8%. So if you put $100 in an account with 8% growth, so you invest your money and leave it for, what's that, 49 years, it will be worth $4,342. Your $100 would turn into $4,342.74. So yes, exponential growth when it comes to money is awesome. Make sure you talk to me about that if you have any questions about how you can get started with investing, because that is my super passion. Another your turn, take a shot at it. Now this one, if you want to take a look at what the equation is, I put it in the yellow box at the bottom, put it into Desmos, play with it a little bit, see, okay, what are the values, what's it approaching, and so on. Pause the video, come back and see how you did. All right, so the domain in this case, it's going forever to the left and down and forever to the right. So this one is going to be negative infinity, less than x, less than positive infinity. X such that negative infinity is less than x is less than positive infinity, and negative infinity, positive infinity, both with round parentheses. Did you get that? All right, inequality notation for the range. Now the range is a little bit harder, and this is where Desmos would have been handy, because you would be able to check these points and see that it never actually gets to 1. So you'll see like 0.999999. It keeps getting closer and closer to 1, but it never actually reaches it. This is an exponential growth curve, but it's going downwards instead of upwards. So inequality for the range, the lowest value, so remember lowest goes first, so it's still going towards negative infinity, less than y, and it's approaching 1, but it never actually reaches it, so neither of those values are included. So negative infinity less than y less than 1. And then we got negative infinity and 1, both with round parentheses. Now, end behavior. As x goes towards positive infinity, what is the y value doing? So as we get bigger on x, y is getting lower, so it's going towards negative infinity. As x goes towards negative infinity, y goes towards, so as x goes to the left, so it goes towards negative infinity, the y value is getting closer and closer and closer to being 1. So not really a trick question. It's definitely something you're going to come across, but keep an eye out for that. Not every answer is going to be positive or negative infinity. It's a good guess if you're ever stuck, but you should be able to do better than that. Like, what is it getting closer to as you go to the extremes of the graph? All right, I want you to take a turn at each of these. You can use a graphing calculator, or you can use Desmos.com, type them in, and then I want to know the domain, range, and end behavior for each of them. So in the first one, If you look at the graph of it, you're going to notice that it is a U-shaped parabola, and the vertex has a height of 1. So our domain is negative infinity, positive infinity. Our range is 1, sorry, that should be a square bracket, 1 to positive infinity. And our end behavior, as x goes towards positive infinity, y goes towards positive infinity, x goes towards negative infinity, y goes towards positive infinity. Apologies for the bad handwriting there. For the second one, it is a linear function, so hopefully you recognize that, and it is going at a slope of -2, so it's going down to the right. And so that would mean domain, negative infinity to positive infinity, both not included. Range, also negative infinity to positive infinity, not included. And end behavior. So for this one, sorry about that, my co-teacher Declan is not being very helpful right now. So as x goes towards positive infinity, so what's happening? It's going down. So as x goes towards positive infinity, y goes towards negative infinity. As x goes towards negative infinity, y goes towards positive infinity. So they are kind of the opposite of each other. And then the last one is a cubic equation. So cubics, you often see the two turning points, and there's kind of a center of symmetry. And then it's, they're all very similar. They're all going to have opposite directions for the end behavior, and then domain range is typically going to be negative infinity and positive infinity. All right, so the domain is going to be negative infinity to positive infinity because it goes from bottom to top. Range, or sorry, from left to right. Range is also going to be negative infinity, positive infinity, and end behavior as x goes towards positive infinity, y goes towards positive infinity. As x goes towards negative infinity, y is going to go towards negative infinity. I'm not sure if you're aware of this, but Desmos has a pretty good phone app. So that's what I usually do. I have the Desmos app on my phone. I just get to go look at it and then type or write my answers down as I go. The online desktop application is also excellent. All right, so just kind of a couple things that you should know. Domain, range, and behavior, we looked at those today. Other things about functions, is it increasing or decreasing, and is the slope of the function positive or negative? We're going to look at that tomorrow, or the next class, I should say. Average rate of change, so between 2 points, what's the average rate of change? Also in our next lesson. Minimum or maximums, you can look at that up on YouTube very easily, like how do I find min and max using my calculator. On Desmos, they're already highlighted for you, so it's a little bit easier there. We will look at it on calculator just to kind of recap on it at some point. Vertex, just identify where the vertex or the turning points are. And then the zeros, which is something that's going to come a little bit later as we go into the different types of functions. So this is just general functions. We will go into the different types. We will start trying to identify zeros on all of those as well. So if any of these are like, oh, I could use a recap on those, it's all Algebra 1 content. Start turning up for our afternoon sessions once they start to get that Algebra 1 content, and maybe take a look at the study packet in Schoology just to see, okay, can I answer some questions about finding zeros? See, what do you remember? What do you need help with? All right, goals for today. What is a function? So a function is we'll say an equation where the input is matched to an output, and there's a single output for every input, so it has to pass the vertical line test. Domain and range, domain is the input, it's the x values on a graph. Range is the output of the function or the y values on a graph. So how do you go from a function to calculator Desmos? You type it in. So on a calculator, you would do the y equals, type it in, hit graph. On Desmos, you get to just type it straight in and it'll show up for you. All right, after this, you should be able to complete Unit 1, Module 1, which is characteristics of functions, and then the folder called domain, range, and end behavior. You should be able to go through the entire playlist and answer the questions at the end. There's an FCPS created video as well if you need extra help or another voice to go through this with you. If you have any questions, that's what we are going to do in the live session. So make sure you are there and you've got your questions ready.